Hello and welcome to the course on Physics for Automobile Engineering. In this video, let us see something about non-destructive testing. So in this modern technology, we are widely using varieties of machines, systems in different fields. Say for example, power plants, industrial plants, chemical industries and so on. So to use some materials in that field, we have to check the condition of the material, whether the material is in good condition or not. There are two types of testings. First one is destructive testing and next one is non-destructive testing. In destructive testing, we can test the material, but we cannot use the sample after that. But in the case of non-destructive testing, after verification, we can use the sample. Let us see the difference between destructive and non-destructive testing. First one is, in destructive testing, the method is applied only to a sample. But in the case of non-destructive testing, this method is applied directly on production items. In the case of destructive testing, tested parts are damaged during testing. But in the case of non-destructive testing, tested parts are not damaged during testing. In the case of destructive testing, different tests cannot be performed on the same item. Meanwhile, in non-destructive testing, different tests can be performed on the same item. And one important point is, in destructive testing, preparation of testing specimen is often required. In non-destructive testing, little or no specimen preparation is required here. Next point, destructive testing, it cannot be performed even to a single part that are in service. But in the case of non-destructive testing, it can be performed on various parts that are in service. In destructive testing, the time consumption to test is high. But in the case of non-destructive testing, it will not consume that much time. Non-destructive testing is commonly employed in shipbuilding, manufacturing of aerospace vehicles, automobile industries, metal manufacturing, electric power plant construction and maintenance. There are around 7 types of non-destructive testing. First one is visual inspection. Second one is liquid penetrant method. Third one is ultrasonic flaw detection technique. Fourth one is radiographic method. In that radiographic method, we have two divisions: X-ray radiography and gamma ray radiography. Fifth method is eddy current testing. Sixth one is magnetic particle testing. Seventh one is thermography. In this video, we are going to see ultrasonic testing method. In that ultrasonic testing method also, we are going to explain something about pulse echo method only. Before going to see ultrasonic flaw detector, we have to know the principle of ultrasonic flaw detector. So the principle is, whenever there is a change in medium, then the ultrasonic waves will be reflected. This is the principle used in ultrasonic flaw detector. Let us see the working of pulse echo method. The pulse generator generates high frequency waves and is applied to the piezoelectric transducer, and the same is recorded in the CRO. So after initiation, a pulse will be generated first. Name this pulse as A. It is our reference pulse. The piezoelectric crystals are resonated to produce ultrasonic waves. So the ultrasonic waves are penetrating through the material and it is analyzing. So the material is not having any flaw in it. Actually here we have some flaw. Consider at first we do not have any flaw in this specimen. If the material is not having any flaw in it, we will not get any disturbance in between. And finally we will get one more peak. Name that peak as P pulse. Consider the material is having some flaw in it. Initially a pulse will be arised. After checking, when it finds a flaw, another peak will arise between A pulse and P pulse. Name of this pulse is called Z pulse. From the distance and the height of the pulse, we can come to know the location of the flaw. So the height represents the depth of